First of all, I'm extremely happy to be at Nordic API Summit. Thank you, Travis and Bill and all the organizers for the opportunity to share my thoughts. Uh, my name is Luis Weir. As of now, I work in Oracle Hospitality. You might not know, but Oracle has a big hospitality suite. Many hotels in the world actually use it to run their properties. I'm working in the team re-architecting the platform based on microservices, and it's completely API-led. But before joining Oracle, I used to work in Capgemini. I was a consultant, chief architect, where I had the opportunity to work with Travis, and I see many of my ex-customers here, which is great. And I was driving API strategies and the full end-to-end implementation as well. So my latest book, Enterprise API Management, it's pretty much the whole 9 yards of API. So you might enjoy it if you're an API junkie like me, and I'm sure you are, because otherwise you wouldn't be in the event. If you want a free copy, I have only 5 right now. Get ready with your phones. Yeah, tweet. The first 5 tweets, I'll give away a free copy. So just take note if you want it. If you don't want it, then you don't have to tweet. You're not obligated to tweet. It's up to you. All right? I'll give it 2 more seconds. I only have 10 minutes, and I talk too much, so I'm going to move on. Opinions are my own. It's a very opinionative presentation, right? I'm representing myself. I'm not talking on behalf of the entire Oracle organization, just so that I don't get fired or anything like that. Okay, now I'm going to go straight to the point. Synchronous communication. What is it, right? I want to level set the definition so I can then deep dive. Well, it's quite straightforward, right? It's things that are happening at the same time, right? So let's say, for example, you're having a lovely conversation with your grandparents, right? That's synchronous. You can even talk with each other, right? The communication is bidirectional. You talk, you can get an immediate response. Another example is, you're having a go at your brother, for example, right? That's also synchronous. You can see the other person, and I don't know what's going on in there, but you get the idea. In terms of what does synchronous communication look like, right? You can see three components in the architecture. You have a consuming application, anything that can consume an API. You have an API exposure layer. I'm using the term exposure deliberately. It could be an API gateway. It could be a load balancer. It could be an ingress in your Kubernetes. It could be a layer 7 web application firewall. It could be a CDN. It could be, I don't know, all the many layer 7 stuff that you have these days, right, on top of your core service, right? And then you have, obviously, a service, which is or microservice, right? I like to use the temp service, right? That basically encapsulates a logic, right? And then, the different patterns that you can adopt in order to deliver a service. But ideally, you expose an API, and that's how your service is accessed. So if we go step by step, right? Synchronous means single HTTP thread. You make a HTTP call, you get a response, right? The response includes the processing of that request, if that makes any sense. Synchronous can be actually very good for many scenarios, especially if you need an instant response, right? It is very useful, right? And in many cases, right, that's what you need. But in other cases, especially when the processing happens at a different time, right, it can be a bit tricky to use synchronous, right? And then you might end up using pooling techniques, right, to try and get around the problem of, I want to get the updates, or which new customers were added, or which new data fields changed, or anything like that, right? And then it's not good, right? Again, I'm not saying synchronous is bad. I'm saying for these use cases, it's perhaps not the best answer, right? So that's kind of what I want to talk about. I want to talk about asynchronous communication and how that translates to the API world. So asynchronous is the opposite of synchronous, which means it's not happening at the same time. Smoke signals are actually asynchronous, right? You do smoke signals, right? And then you don't know if the other person got them or not, right? And then there is SOAP. That was a bad joke. Anyways, you're familiar with asynchronous, right? In your day-to-day messaging, right? I mean, when you get notifications, push notifications, that's all asynchronous communication. So asynchronous communication is part of our day-to-day life. We do it all the time, but we also do synchronous communication, right? But don't overdo asynchronous communication, because then that's not actually me, but it is me sometimes. So, just a tip, right? I want to use an analogy to walk you through asynchronous in the real world, right? Have you ever wondered what does the name in the cup means from a programming software development point of view? I'm sure, I'm not going to talk about brands, right? But I'm sure you recognize which brand, implements this process, although many brands do it like this way. What the name represents is actually a unique identifier. That's what it is, really. And why is it there? Well, it's there to allow non-blocking processing. So once the name is in the cup, I need to get out of the queue. I need to let someone else come and make the order. I move to the side, right? And then it can be asynchronous delivered. So let me walk you through step by step quickly what happens, right? So the lovely lady writes my name in the cup, the UUID, right? Hopefully she spells it right. Then the barista makes the coffee. I'm already out of the queue. I'm stepping to the side, waiting for it, right? So it's a non-blocking execution at that point. It's a command that's been executed. And then the order is completed, delivered, and my name is called out, right? To make sure that the response or the actual delivery corresponds to the person that made the order. And that's how you do the correlation. So this example, I think, is quite illustrative, right, and representative of how asynchronous actually works in the real world. It's not far off, right, from how we do it in APIs. So if I have to define APIs, which I'll do in a second, it's also important to take into account the web, the World Wide Web. There are many constraints that if you don't take into account, you can end up in situations where you spend more time trying to, get the IT department to unblock firewall rules, right? Because you're using a, unsupported protocol or something like that, right? So just to be clear, right? Layer 7 applications, right, are all over the place, and things like load balancers, API gateway, firewalls, as I mentioned before, you have to take them into account when you're going to implement APIs, and even asynchronous APIs. Majority of firewalls will block non-HTTP traffic. This is not necessarily a showstopper, but it can be a pain in the neck, right? So you need to be aware of this constraint. And JSON is still very, very popular, I would say, in the modern API world. It's probably the most popular payload, but then you start seeing things like Avro in Kafka or protocol buffers in gRPC that are more and more becoming prevalent. So in HTTP 2, which I think is awesome, and if you haven't read about it, I do recommend that you read a little bit about it. It's really introducing some killer features. I'm not going to deep dive in HTTP 2 today, but I do recommend that you read about it, right? Long story short, what I want to say is that you need to take into account the OSI or TCP model, right, when you're architecting for the web. And at the end of the day, you have a lot of protocols across the stack, but it's probably a handful that you need to be aware of, right? And this is extremely important. And it's extremely important because the asynchronous API market or the technology landscape for asynchronous is booming. I swear to you, this slide took me, I don't know how long to make. When I started doing research, I started finding out, okay, you have transport. Then on top of transport, you have things like WebSockets. But then now even MQTT support WebSockets, right? But also those ActiveMQ. But then, HTTP 2 is there as well. So anyways, I did a research. I tried and create a diagram that shows that makes sense in my head, right? And hopefully it makes sense to you as well. I'm not going to explain everything in detail, right? But the reason I did this is I wanted to kind of shortlist, right, the key trendy protocols that I want to deep dive in today. Let me ask you a question. Raise your hand if you know what SOAP WS addressing is. Okay, you just told me your age. So we can have a conversation about SOAP tonight. It's actually an asynchronous protocol developed a long time ago, like probably 15, 20 years ago, I would say. I did implement it once or twice, right? But then you have things like long polling, right? Who knows who XMPP is? Raise your hand. Okay, only like 2 guys. Raise your hand if you use WhatsApp. Okay, I know everyone, yeah. So WhatsApp uses XMPP, and it's actually a long polling protocol. It's actually just opening a HTTP thread and never closing. That's how you simulate a push event. So it's not really push, although it emulates push, right? So if I was to kind of cherry pick what's relevant to today, I wouldn't say Kafka is bad, right? But if you go use Kafka protocol, right? Kafka protocol is based on TCP. And then you have all the issues with the firewalls I mentioned before. So if you're using Kafka internally within your service-to-service microservice boundaries, then it's great. But if you're using Kafka native to then have intercompany, right, exchange, right, or asynchronous communication between company A and company B, trust you me, you're going to have challenges with the communication, right? Same with MQTT. MQTT is great, although now you have the MQTT over Stomp, which is actually a WebSocket protocol. So you can get around the constraint. But if I was to cherry pick, then I would say these are probably the most relevant these days because they are based in HTTP, right? And even WebSocket is broadly supported today. Now, how do I filter from here? How do I know which ones are the best, right? Like, for example, Bolkine is super recent, but I love the concept, right? They're kind of trying to do what GraphQL does, but using HTTP2 natively, right? So I did a quick Stack Overflow analysis. I think it's important. I like a Stack Overflow because it's actually from a developer's point of view. So if you're implementing the technology, you're going to have issues. Everyone has issues. Then you're going to go to Stack Overflow. You're going to capture the issue. You're going to have a discussion, right? And then you can find trends in Stack Overflow. So I'm not saying the ones that I couldn't find are bad by any means. That's just the outcome of my analysis in Stack Overflow. There are different ways to look at it, right? I added REST just to show how relevant it still is, right? It's still pretty relevant, right? But then you can see that GraphQL is still pretty relevant. It's growing in popularity like crazy, right? MQTT is pretty relevant, but I couldn't make the decision in MQTT whether it's MQTT native or MQTT over Stomp, therefore HTTP with WebSocket. So I kind of said, okay, I'm going to filter them out like this. It's my take on trendy asynchronous protocols, right? So I want to talk about WebHooks. I'll explain in a second what I mean by WebHooks or what WebHooks are. I want to talk about WebSockets, and then I'm covering all the protocols that go on top of WebSockets, like MQTT over Stomp, for example, or ActiveMQ over Stomp. I want to talk about GraphQL subscriptions, and also GraphQL live queries. I should have put that in there. I think GraphQL is becoming more relevant these days, so I think it's important to at least be aware of how it works. And gRPC, which I really like it, right? But it's also interesting in terms of how it works, right? So let me go one by one. Sorry, I'm going a bit fast, but I have 20 minutes, and I do want to finish my presentation. Yeah, it's important to finish it. So webhook APIs, sometimes it's called REST hooks, right? And I think it's obvious why, right? Basically, you subscribe through a URI, right? So it can be nicely implemented alongside a REST API, right? But once you register to a particular event, for example, I subscribe to an event for customer updates, right? And that's a URI that you call and you provide your callback details, right? You provide a URL for the callback. That means that the message request and the message response are in two completely separate calls, as you can see in the diagram. So you make a request, you get a 200 response saying, yeah, I got this, or it's created. But then there will be another reverse call. I think that's the next, the next bullet point. Then you make a reverse HTTP call saying, this is the response of your request. What this means is that the HTTP request and response are fully detached from the actual process, right? Or the command that you're trying to accomplish, right? Pretty much the analogy I gave of Starbucks. Obviously, you need a pub sub system, some way of capturing events, right? Because now you're completely detached from the main HTTP thread, so you need to know, okay, I know that this consumer is subscribed to this event, right? But there may be many consumers subscribed to the same event. Then you need to be able to filter events that are relevant for parties, and you need to have the capability to call back, right? So implementation-wise, it can be a bit tricky. That's just an idea on how you can implement it. There are many ways to do it, right? But actually, I've done that, and it can work, right? And the interface is actually already supported in the latest version of the Open API specification 3.0. There's actually a callback element that you can use to define. I know that the Async API spec, Frank actually mentioned to me, Frank Mendes, who created the specification, mentioned to me in a tweet that they're working on examples. I haven't seen it yet, but I just thought it was worth it of adding it. And I know that you can also model the domain, right, for any API using supermodel.io that I believe Seth, who wrote my foreword for the book, is going to talk about tomorrow. These are some examples of webhooks APIs. They are plentiful. But I want to highlight W3C. It's interesting that webhooks is actually not a standard, not even by W3C, but they're using it, in their own API. Maybe it should be a W3C standard. I don't know. WebSocket APIs. So WebSockets are really interesting. Basically, you create a socket by making a HTTP call and then asking for an upgrade on your connection. That's pretty much how it works, right? And the majority of browsers already support the WebSocket protocol. And once you create a WebSocket, right, that actually creates a duplex bidirectional communication, right, between your consumer and your server. And that's pretty, pretty cool. And I can see a rise in WebSocket APIs. But needless to say, the browser then needs to support WebSocket, otherwise, it would be a bit tricky, right? And the interface is actually fully supporting the API in the Async API spec. In fact, I saw a few examples. Maybe I can move to the examples now of Async APIs. For example, Slack is using asynchronous APIs based on WebSockets. So I think it's really, really interesting. I haven't done WebSocket APIs, started experimenting with it, but I think you should keep an eye on it because it's becoming very, very popular. The next one I want to talk about is GraphQL Subscriptions. And the diagram is actually simplified. So I did find it a bit, getting my head around it wasn't straightforward at the beginning, right? Raise your hand if you're familiar with GraphQL. Oh, that's very good, because I don't want to talk about what GraphQL is, how it works. So I'm just going to explain subscriptions. So basically, the way it works is, almost like WebHooks, you subscribe through, in this case, through an operation. So it's a specific type in GraphQL called subscription. And then within the subscription type, you specify what event you want to subscribe to. It's transport protocol. Actually, the specification doesn't tell you need to use WebSockets, or you need to use server-side events, or you need to use whatever it is that you want to use. However, the two most popular implementations that at least I found, right, is Sangria, which is server-side. It's the first one, actually. And you also have WebSockets, which is Apollo, which I would say is perhaps the most popular one, given that Apollo is really adding a lot of value in the GraphQL community. It's a read-only push. Even if you establish a WebSocket, it's only going to be one direction, right? So it's not like you open the socket and then you can do two ways. Are client-driven, and this is a pretty good feature, cool feature I find, right? So when you subscribe to an event, you also specify in the subscription payload what events, what data fields you want within the event itself. Right? So not just you're subscribing to the event, but then you're also specifying, only send me this data for the event, right? So it's pretty cool, I think, that feature, and I would say that's a plus in the GraphQL subscription approach. It does require a pop subsystem, right? And that's because the way it works is when you do a mutation, which is equivalent to a post, put, patch, or delete in HTTP REST, you need to trigger, right, or inform the pop subsystem that something has changed, right? And when you inform the pop subsystem, then that triggers back, right, the push, right? And that's how pretty much you establish the event stream in the subscription approach within GraphQL. And the GraphQL implementation has its own schema definition language, but I know that also the Async API are working on defining subscriptions with Async API spec. I'm going to go to the next one. I have 3 minutes left, and I have a few more content to cover, right? So live queries. I'm just going to skip a little bit the bullet points, right? It's similar to an extent to subscriptions. The main difference is that there is no subscription type. They use what's called directive. And the way the directive works, if you see that on the top left, you put live and then a query, right? And then what that's telling the server is, please create a transport and tell me whatever changes in the query. And the way it works is you need to implement a reactive stack, which is for me another complexity, like, I don't know, RxJS, right, if you're using JavaScript. And by using a reactive stack, you can use something like, I don't know, telling queries, right? And then you know at the database level, right, this changed, and then you can stream it back to the consumer. I'm showing some examples here. So Facebook and Samsara have some pretty cool videos on how they implement live queries. But subscriptions are actually popular as well. I'm giving 4 examples two of each for you to later to see. gRPC, right? Who've heard of gRPC? Oh, wow, this audience is advanced. Best audience, yeah. So it's using HTTP2, but it's not just HTTP2, it's using protocol buffers, right? Which is a serialization. And this serialization protocol developed by Google. It's an open. I don't think it's not a standard industry standard, but it's open sourced. But it's also an interface definition. If you define a .proto file, that's your interface as well. And using the .proto file, then I'll say it in a second, you can generate your stops and your servers. It supports. The reason I really like it is you have 4 schemes. You can support one way, 2 ways, or fully bidirectional schemes. I already said that. And it is possible to support HTTP 1.1 if you implement a bridge, right? But then you're adding complexity. You also need to use a gRPC web client, a special client for browsers, right? So then you're adding complexity to your stack. So I would say it's perhaps not the most user-friendly. So now to wrap up, and I have 40 seconds to finish this, right? This is my subjective analysis on pros and cons. There is no one size fits all, yeah? You need to look at your use case and make your decision what option is best for you. I'll walk through 3 examples. Let's say you need a server to browser. Probably WebSockets and GraphQL are the best options, right? As I said, gRPC can be complicated. WebHooks, you can't really. Are you going to implement a server in your browser? Well, I haven't heard of that, but if you've done it, please tweet it, and I'll see how you did it. Server to server, maybe WebSockets, and it's possible, right? But maybe, it's not straightforward. Webhooks and gRPC are probably pretty good options. For intercompany, I would say Webhooks, and internal microservices, I would say gRPC. I ran out of time. I don't want to consume my time from the next great presentation. I was a bit quick. Thank you very much.